The birth and death of stars on a cold night in the desert, far from city lights. You can look up and see a river of stars spilling across the sky. Each pinprick of light seems fragile, like something that could be blown out with a single breath. Yet nothing could be further from the truth. Stars are not delicate candles. They're titanic furnaces, burning with a power so fierce it defies comprehension. They are born in silence. They blaze for millions or even billions of years, and when their time runs out, they die with a violence that can shape galaxies. Every star you've ever seen has a story, a life cycle as dramatic as any myth. To understand it, we must start where stars themselves begin, in the coldest, darkest corners of space. The stellar nursery between the stars, space isn't empty. It's filled with clouds of gas and dust, invisible to the naked eye, but revealed in breathtaking color through the lens of telescopes. These clouds, called nebulae, are the cradles of stars. For millions of years they drift, enormous and quiet, until something, perhaps a nearby supernova shockwave, perhaps just the random tug of gravity, disturbs the balance. When that happens, a region of the nebula collapses under its own weight. Slowly, steadily, hydrogen atoms begin to crowd together, pulled by gravity into a tighter and tighter knot. As they fall inward, they heat up. A dim glow flickers, grows brighter, until one day a line is crossed. The core becomes hot and dense enough for nuclear fusion to ignite. Hydrogen atoms smash together to form helium. In that moment, a star is born. The night sky, scattered with glittering points, is nothing more than billions of furnaces running on fusion, each one fighting against gravity's pull with the energy of light itself. Without fusion, gravity would crush the star into darkness. With it, the star holds steady, shining for eons. The prime of life, our own sun, is a middle-aged star. It has been burning for 4.6 billion years and will burn for about 5 billion more. To us, that sounds like forever. But in the cosmic storybook, the sun is ordinary, a yellow dwarf, content to burn hydrogen and radiate warmth. Bigger stars live faster, hotter, and die younger. A star 10 times the mass of the sun burns its fuel so quickly that it might last only a few million years. A star half the sun size might burn slowly for hundreds of billions of years, longer than the universe itself has been around. Stars are the great alchemists of the cosmos. In their cores, fusion doesn't just make light. It forges elements. Carbon, oxygen, nitrogen, the building blocks of life, are created in the fiery bellies of stars. Every breath you take, every cell in your body, every piece of the earth beneath your feet is made of stardust. We are quite literally the children of stars. The end game, but nothing lasts forever. Eventually, a star runs out of hydrogen fuel. Without fusion to push outward, gravity begins to win. The star changes, swells, transforms. If it's a star like the sun, it expands into a red giant, so vast it might swallow nearby planets whole. Imagine the sun growing so large its outer layers reach all the way to Earth's orbit. The sky filled not with a gentle yellow disk, but with a swollen, fiery orb that dominates the heavens. After shedding its outer layers, such a star shrinks to a dense ember called a white dwarf, which slowly cools over billions of years. But for massive stars, the ending is far more dramatic. When their fuel runs out, their cores collapse in an instant, triggering a supernova. The explosion is so bright, it can outshine an entire galaxy. For a brief time, the death of one star can illuminate the universe. Supernovae are not just fireworks, they're factories. In those titanic blasts, elements heavier than iron are forged: gold, uranium, all the rare treasures of the periodic table. Without supernovae, there would be no jewelry, no electricity, no planets like Earth. And sometimes, the collapse goes even further. If the star is heavy enough, nothing can stop gravity. The core collapses into a single point of infinite density, a black hole. Invisible, silent, yet powerful enough to warp spacetime itself. Black holes are the universe's way of recycling matter into mystery. The cosmic cycle death, however, is not the end. The gas and dust expelled by dying stars scatter across galaxies, mixing into the interstellar medium. Eventually, they drift into nebulae again, where new stars are born. Out of death comes life, and the cycle begins anew. The starlight that warms your face on a summer afternoon is powered by nuclear fire. Yes, but it is also a message. It whispers across space and time. I was born in darkness. I burned in fury, and one day I will die so that others may live. Every night sky is a cemetery and a nursery. Some stars you see are young. Some are ancient. Some are already gone. Their light still traveling across the void, long after their bodies have vanished. To look up is to look back in time, to witness the past as it shines into our present. And perhaps the most astonishing truth of all is this: the universe wastes nothing. The death of one star becomes the cradle of another. And in this endless cycle, against impossible odds, life emerged. Us, sitting here on a tiny planet, telling stories about the stars that gave us birth. The immensity of planets on Earth. We think of planets as familiar things. We know their names like members of an ancient family. Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune. They orbit our sun, each with its own character, some gas, some rock, some fiery, some icy. But the truth is, these 8 worlds are barely the opening notes in the symphony of planets that fills the universe. When astronomers first turned their telescopes to the heavens, they thought planets were rare. After all, for centuries Earth was the only one we knew. Even after we discovered the rest of our solar system, many believed our little arrangement might be unusual, a lucky accident. But in the last 3 decades, everything has changed. We now know there are billions upon billions of planets in our galaxy alone. They orbit nearly every star, like dust motes caught in sunlight. And many of them are nothing like the tidy worlds we grew up memorizing in school. The exoplanet revolution in 1995, 2 Swiss astronomers, Michel Mayor and Didier Queloz, discovered the first planet orbiting another star, a gas giant circling a star called 51 Pegasi. The world was a shock. It was huge, bigger than Jupiter, but it orbited incredibly close to its star, completing a year in just 4 Earth days. The textbooks had to be rewritten overnight. Since then, we've found thousands of exoplanets, planets outside our solar system, using space telescopes like Kepler and TESS. The numbers are staggering. More than 5,000 confirmed worlds, and that's just the beginning. Statistically, scientists now estimate there may be more planets than stars in the Milky Way. That means hundreds of billions of worlds, each unique, each with its own story. Think about that. For every star twinkling above you, there's likely a retinue of planets circling unseen. The universe isn't just sprinkled with worlds, it's drowning in them. Stranger than fiction, some of these planets are so bizarre they sound like science fiction. Take HD 189733b, a gas giant where the winds howl at 5,000 miles per hour and it rains shards of glass sideways. Imagine standing there, though you couldn't, and watching glittering storms of blue glass cut through the skies like diamond dust. Or Kepler 10b, a rocky world so close to its star that its surface is hotter than molten lava. The planet glows like an ember, seas of magma rolling across its face. There are rogue planets, too, worlds not bound to any star, drifting alone through interstellar space. Imagine an endless night, a frozen wasteland illuminated only by the faint heat left in its core. Billions of these lonely wanderers may roam the galaxy, unseen, waiting. And then there are the super-Earths, planets bigger than our own but smaller than Neptune, common in the galaxy yet strangely absent in our solar system. Some might be rocky giants with mountains taller than Everest, others vast oceans stretching for thousands of miles with no land at all. If life exists out there, perhaps it thrives not on Earth like twins, but on these strange cousins. The question of life, the immensity of planets, naturally leads to the question, if there are so many, how many harbor life? Astronomers talk about the habitable zone, the narrow band around a star where temperatures are just right for liquid water to exist. In our solar system, Earth sits comfortably in this zone, while Venus and Mars hover on the edges. When Kepler surveyed the sky, it revealed that small, rocky planets in habitable zones are common. By some estimates, there may be tens of billions of potentially habitable planets in our galaxy alone. Even if only a fraction of them actually host life, the number is still staggering. And life doesn't need to look like ours. Some of Earth's strangest creatures, bacteria thriving in boiling acid pools, shrimp huddling around hydrothermal vents in pitch-black oceans, prove that life can adapt to conditions we once thought impossible. If life can flourish in such extremes here, what might it do on a frozen moon warmed by tidal forces, or a planet where the atmosphere is thick with methane? Perspective shift, there's a humbling truth here. For most of history, humans believed Earth was unique, the center of creation. Then we discovered we orbited the sun. Then we learned the sun was just one of billions of stars in the galaxy. And now we know that nearly every one of those stars has its own planets. Earth is not the jewel of the cosmos. It is one pebble in an infinite beach. But instead of making us small, this knowledge expands us. Because when you realize there are countless worlds out there, you also realize there are countless possibilities. Somewhere among those billions, another blue planet may orbit a gentle star. It sees teeming with creatures that gaze up at their own night sky and wonder if they're alone. The story continues as Daniel Cross, if we continue from our narrative framing, might have thought staring at the desert sky. The truth isn't just above us, it's multiplied across every corner of the galaxy. Planets we'll never see, worlds stranger than any dream, some dead, some alive, some waiting to be found. The immensity of planets is not just a fact, it's a promise. A promise that the universe is far richer, far stranger, and far more alive than we dare to imagine. Black holes. The universe's monsters imagine a place where the laws of physics, as we know them, collapse. A place where space bends so steeply that nothing, not even light, can climb back out. That's what a black hole is. Not an object in the ordinary sense, but a pit in the fabric of reality itself. To look at a black hole is to look at the universe's most ruthless secret. For centuries, the idea was pure speculation. Even Einstein, whose equations hinted at them, doubted they could exist. But today we know better. Not only are black holes real, they're everywhere, hiding in the hearts of galaxies, scattered through the Milky Way like dark seeds. The making of a monster, a black hole, begins its life like many cosmic dramas, with a star. Not just any star, but a giant 10, 20, 50 times more massive than our sun. When such a star burns through its nuclear fuel, gravity takes control. The star collapses inward with unimaginable force. If the mass is great enough, nothing halts the collapse. The core shrinks smaller and smaller until it becomes a singularity, a point of infinite density, where space and time themselves are torn apart. Around this singularity forms the event horizon, the boundary beyond which escape is impossible. Step across it, and you're gone, swallowed by the monster. The event horizon to the outside observer. The event horizon is the ultimate point of no return. Not even light escapes, which is why black holes are invisible, revealed only by the havoc they cause. If a black hole drifts near a star, its gravity tears gas away, forming a glowing disk of matter spiraling inward at nearly the speed of light. This accretion disk shines with such violence that black holes, ironically, can become some of the brightest objects in the universe. Einstein's relativity tells us something even stranger. To someone falling into a black hole, time feels normal. But to someone watching from a safe distance, the infalling person seems to slow, then freeze at the horizon, stretched by gravity's pull. They never appear to cross the line, though in their own experience they do. Time itself fractures at the edge of a black hole, making it not just an object, but a paradox. Supermassive beasts, if stellar black holes, are monsters. The ones at galactic centers are titans. Supermassive black holes contain millions, even billions of solar masses. Our own Milky Way harbors one called Sagittarius A*, a behemoth weighing 4 million times the Sun. No one knows exactly how these giants formed. Did they grow from smaller black holes, feeding for billions of years, or were they born enormous in the early universe? What we do know is that their presence shapes galaxies. They anchor stars, influence orbits, and sometimes flare with eruptions so powerful they outshine the galaxy itself. In 2019, humanity saw one for the first time, not with eyes, but with radio telescopes spread across Earth, linked together as a planet-sized observatory. The result was the now famous image of the black hole in galaxy M87, a fiery ring of gas surrounding a shadow of nothing. For the first time, we looked into the abyss and saw its silhouette staring back. The physics of the impossible black holes are not just curiosities. They are laboratories where the universe conducts experiments we can't replicate. At their edges, matter is crushed, time dilates, and energy bends in ways that defy ordinary physics. Some theories suggest black holes could be gateways, wormholes to other universes, shortcuts through space-time. Science fiction has run wild with the idea, from Interstellar to countless novels. But reality is harsher. Wormholes, if they exist, would collapse too quickly to use. Still, the equations leave the door cracked open. And what happens at the singularity itself? No one knows. General relativity predicts infinite density, but quantum physics rebels against infinities. Somewhere in the mathematics lies a deeper truth, a new law of nature waiting to be discovered. Black holes are not just monsters. They are clues, whispering about the next revolution in science. Death by black hole for all their grandeur. Black holes are killers. Get too close, and their gravity stretches you into what scientists call spaghettification. Your feet, being closer, are pulled harder than your head, and the difference grows so extreme that you're stretched into a thin, unrecognizable thread of matter. To fall into a black hole is to be undone. And yet, even these cosmic monsters die. The great physicist Stephen Hawking discovered that black holes slowly leak energy, a faint radiation at their edges. Over unimaginable timescales, they evaporate. A stellar black hole may take longer than the age of the universe to fade, but eventually even the darkest giants vanish into nothing, leaving only whispers behind. Why they matter? It's tempting to think of black holes as freak accidents, irrelevant to life on Earth. But they are central to the universe's story. Without black holes, galaxies might never have formed in the way they did. Without galaxies, stars like our Sun and planets like Earth might not exist. Even the monsters have their purpose. When you look up at the night sky, you won't see a black hole staring back. But somewhere in the darkness between stars, they are there, silent, hungry, waiting. And if stars remind us of creation, black holes remind us of limits. They're the universe's way of saying, there are places you cannot go, truths you cannot touch, boundaries that even light cannot cross. And yet we keep looking, because sometimes staring into the abyss is the only way to learn what it means to be alive. Neutron stars and pulsars of black holes are the monsters of the universe. Then neutron stars are their strange cousins. Objects so bizarre they sound like something dreamed up in a science fiction lab. And yet, They are real. They're the densest, strangest remnants of dead stars. And in their own way, they may be even more astonishing than black holes. The collapse after death picture a star much larger than our sun, burning bright for millions of years. When it finally exhausts its fuel, it collapses just as a black hole candidate does. But if the mass isn't quite enough to trigger a full collapse, the core halts. Not into a black hole, but into something else. Gravity squeezes the atoms so hard that the protons and electrons are forced together, fusing into neutrons. The star is crushed into a sphere no bigger than a city, but containing more mass than the entire sun. Imagine compressing Mount Everest into a teaspoon. That's the density of a neutron star. The extreme world, everything about neutron stars is extreme. Their gravity is so powerful that a person weighing 150 pounds on Earth would weigh billions of tons on their surface. Their crust is made of matter so tightly packed it would take 1 billion times the pressure of Earth's core to crack it. And their magnetic fields? Some neutron stars, called magnetars, have fields so strong they could wipe a credit card clean from halfway across the moon. If you stood anywhere near one, the field would twist your very atoms apart. Yet from afar, they are small, faint points of light, stars that died but didn't quite vanish. Pulsars, the universe's lighthouses. In 1967, a young graduate student named Jocelyn Bell noticed something odd while analyzing radio signals. The telescope picked up regular, rhythmic pulses like a cosmic heartbeat, coming once every 1.3 seconds. At first, she and her advisor jokingly labeled it LGM for little green men, wondering if it could be an alien signal. It wasn't aliens. It was a new kind of star, a pulsar. Pulsars are neutron stars that spin rapidly, sometimes hundreds of times per second. Their magnetic poles emit beams of radiation that sweep across space like lighthouse beams. Every time one of those beams crosses Earth, we see a pulse of light or radio waves. Some pulsars are so regular that they rival atomic clocks. If you want to tell the time in deep space, forget your wristwatch. Bring a pulsar. The fastest spinners among the most astonishing are millisecond pulsars, neutron stars that spin more than 700 times a second. That means a city-sized object, heavier than the sun, is rotating faster than a kitchen blender. How can anything that massive move so fast? Gravity holds it together. If Earth spun that quickly, it would tear apart instantly. Astronomers believe some of these pulsars are recycled, spun up by stealing material from a nearby companion star. As gas falls onto the neutron star, it transfers angular momentum, whipping the star into a dizzying spin. It's cosmic theft, and the thief becomes a beacon shining across the galaxy. Why they matter? Pulsars are not just curiosities. They become essential tools for science. Their extreme regularity lets astronomers test Einstein's theory of relativity in ways no laboratory on Earth can. By studying pulsars and binary systems, scientists have observed the tiny ripples of space-time caused by gravitational waves, predicted by Einstein, confirmed decades later. And there's another astonishing possibility. Some astronomers dream of using pulsars as navigation beacons for spacecraft. Just as sailors once steered by earthly lighthouses, future explorers could cross the stars guided by pulsars, their cosmic clocks ticking in the silence of space. The human perspective neutron stars remind us how strange the universe really is. They are stars that died, but in their death, they created something new, objects that defy intuition yet obey the deepest laws of physics. If you stood near one, though of course you never could, you would see nothing like the earthly sky. The horizon would curve sharply beneath you, as though you were perched on a ball far smaller than our planet. The ground would be harder than diamond, the gravity irresistible, the magnetic field clawing at your atoms. And above you, beams of light would sweep the cosmos, broadcasting your star's existence across unimaginable distances. It would be alien, terrifying, and beautiful. The cycle of extremes, neutron stars are part of the same story that gave us black holes and supernovae. They are a reminder that stars do not simply fade away, they transform. The universe is a machine for creating extremes, for pushing matter and energy to their breaking points, and then showing us what happens next. And sometimes, the results are so strange they make us laugh at our own imagination. A spinning city-sized star? A magnetic field that can tear molecules apart? Pulses of radio waves more reliable than the clocks we build? These things exist. They're not dreams, not metaphors, not inventions of science fiction. They're real. The night sky is filled not just with twinkling points of light, but with hidden clocks ticking and spinning in the dark. If you close your eyes and listen with the right instruments, you can almost hear it, the steady beat of dead stars, keeping time for the universe. Dark matter and dark energy, the night sky is full of stars, galaxies, and glowing gas. But what we see is only a tiny fraction of reality. The strangest truth of all may be this: the universe is mostly made of things we cannot see, cannot touch, and can barely even understand. Scientists call them dark matter and dark energy. Together, they account for about 95% of the universe. That means everything we've ever known, planets, stars, galaxies, the very atoms in our bodies, makes up less than 5%. We live in the margins of reality, surrounded by an invisible majority. The mystery of dark matter in the 1930s, astronomer Fritz Zwicky studied galaxies and noticed something odd. The stars at the edges of galaxies were moving too fast. By the laws of gravity, those galaxies should have torn themselves apart. The only explanation was that something invisible was holding them together, some hidden mass that exerted gravity but gave off no light. That something became known as dark matter. We can't see it, but we see its fingerprints everywhere. Galaxies spin too quickly. Clusters of galaxies bend light from behind them, a phenomenon called gravitational lensing. And the structure of the universe itself only makes sense if there's an invisible web of matter holding it together. But what is dark matter? We don't know. It could be exotic particles that barely interact with normal matter, or something stranger we haven't imagined. Billions of dollars of experiments are searching for answers, but so far the mystery holds. The even greater mystery of dark energy, as if dark matter weren't enough. The universe hides an even stranger secret. In the 1990s, astronomers measuring distant supernovae discovered that the universe's expansion was speeding up. That made no sense. Gravity should be pulling everything back together, slowing the expansion. Instead, some unknown force was pushing it apart. We call it dark energy, a name that's more confession than explanation. It's a placeholder for ignorance, a recognition that something vast and powerful is at work. Right now, dark energy makes up about 70% of the universe. It is the dominant force shaping the cosmos. Yet we don't know what it is, why it exists, or whether it will change. The invisible universe, think about it. Most of reality is invisible. We go about our lives on Earth believing the universe is made of stars and galaxies, when in truth we are living in a thin slice of the real story. We are shadows playing on the surface of an ocean, unaware of the depths below. But that ignorance is not defeat. It is invitation. Every mystery, dark matter, dark energy, is a frontier. It tells us there's more to find, more to learn, more to explore. And perhaps most humbling of all, we might never have all the answers. The universe may be too vast, too strange, too alien for the human mind to fully grasp. But maybe that's the point. The beauty is not in having the final answer, but in the endless pursuit. Epilogue. The endless sky. We have walked through stellar nurseries where stars are born, watched planets whirl in impossible variety, and stared into the abyss of black holes. We've listened to the heartbeat of pulsars, glimpsed the invisible scaffolding of dark matter, and felt the accelerating breath of dark energy. And yet, even after all of this, the universe is larger than our questions. To live as a human is to stand on a small planet orbiting a middle-aged star in one galaxy among billions. Our lives are brief flashes compared to cosmic timescales. And yet, within those flashes, we dare to ask, what is this? Where did it come from? What does it mean? The answers we've found so far are astonishing. Stars are born, live, and die, creating the elements of life. Planets are countless, stranger than imagination, and maybe alive with their own stories. Black holes and neutron stars stretch physics to its breaking point. Invisible forces, dark matter and dark energy, dominate everything. The universe is expanding, evolving, and one day will face an end. But the greatest truth is this: the universe is not a riddle to be solved once and for all. It is a story, and we are part of it. Every discovery is a new chapter, every mystery an invitation to keep reading. So the next time you step outside at night, look up. See the stars, yes, but also imagine what you cannot see. The unseen worlds, the silent monsters, the hidden forces, the future still unfolding. The universe is whispering to us across light years, across centuries, across the silence of space. And if you listen closely enough, you'll realize the story has only just begun.